Okay, so I'm going to add a little something to number 7 right here too, because I did not put the horizontal asymptote stuff in here. I put it on, well, I didn't even really use the word horizontal asymptote on range, but you need it for range. So, excuse me. Here, they're just asking for all the discontinuities here. So, it gives you a graph. You're just looking at the graph. If there is a hole on a graph such as this and you don't have an equation for it, they will show you that by putting an open circle. So, we do have a hole for this one. And in preparation for our delta math, we're going to do a delta math. Hopefully it will work. Delta math was working okay today. For our delta math, I really don't care that much about this. What I'm really concerned about is the x-coordinate of that hole. Okay? So where is my x-coordinate of that hole on this graph? I think I heard it. -5, right? Right here, our x-coordinate right there is -5. So it's perfectly fine just to say there is a hole at x equals -5. That's okay. But on delta math today, it is going to ask you to give both coordinates of the hole. Now here's the problem, is that on Desmos, if you go to that point, it's going to have, like, -5 will be the x-coordinate, but it's going to say undefined for the y-coordinate. What it's looking for is what the y-coordinate of that point would be if it were defined. So it's not wanting you to put undefined there. So I really don't care about this, but I just want a guess. This is really like a little beyond what we actually have to do. Like in calculus, we learn how to do this for sure, but it involves limits and stuff. Like, we're definitely not going there, nor are we expected to go there with what we're doing. So here's what I want you guys to do. You're probably going to miss some of these. It's okay because of the y-coordinate here. Here's what I want you guys to do. I just want you to guess at what the y-coordinate of that is. What does it look like it would be here? It's not a whole number. I would almost agree, but it would not be positive 0.9. It's below the x-axis, so it'd be like -0.9 or 0.75 or whatever. Take a guess at it. I just want you to guess at it and put it into delta math. It's going to make you like miss some of those if you don't guess it correctly. It's okay. That's not in our curriculum. Delta math won't let me take that part off of the questions that it's given. So we're just going to guess at it on delta math. What we're really concerned about is the x-coordinate being correct. If you're getting the x-coordinate correct, then fine. We also have some vertical asymptotes here. Where are my vertical asymptotes for this problem? Thinking about where we could put like a vertical line. +3. That'd be right here. I believe that looks lovely. Now, we don't want to just give the number here. We have to give the equation of that line. What is the equation of a vertical line? What? X equals. So we'll do x equals +3. Hannah, what's the other vertical asymptote on this one? Okay, I believe you're right. X equals -2. Also looks good right there. Okay, so you are just pulling that from the looks of the graph here because they don't give you an equation. Right. So anytime you see that graph going like this, that's whenever you're having those vertical asymptotes. Sometimes it does like this or like this. Also, they could like go the same direction, but a lot of times it's like that. So one other thing that I didn't mention, but I want to throw in here because I didn't use the term and I should have, is a horizontal asymptote. and we're going to do a little bit of these, but we're going to go by looks on these and not so much like the equation itself. We might have to look at the equation a little bit, but another thing about a horizontal asymptote is you really care about what's happening out on the ends of the graph. Because normally, I would say an asymptote is a line that you get closer and closer and closer to, but you never touch. Does this graph ever touch that green dotted line? What about right here? It does cross it right there in the middle. But when you have these types of graphs that like have multiple pieces to them, you might have, particularly like that middle piece might actually cross your horizontal asymptote, but what we care about is what's happening out at the ends of the graph. And at the end of this graph, you're getting closer and closer and closer to 0, and over here, you're getting closer and closer and closer to 0. So this would still be considered a horizontal asymptote here. So that horizontal asymptote, horizontal lines, what are their equations? Y equals, so we would say y equals 0 for that. Okay, and we're going to go primarily off of looks. I'll show you one trick. If it's not a whole number, sometimes it's a little hard to see. If you see a horizontal asymptote, it is going to be given as a multiple choice problem, so you should be able to type it in for those. So let's look at the last slide. This slide asks us for something slightly different than what we were looking at before, but only slightly. These ask for the domain. Domain is all the possible x values that you can plug in. What we've been finding so far are holes and vertical asymptotes. These are discontinuities. We've been looking at where the domain does not exist, where we have a problem with the domain. Really the only main difference that you're going to see here is that in the way that we present our answers. So if they ask us for the domains, they're asking for the numbers that do work, not the numbers that don't work. So whenever I look at these, it really doesn't matter if you have a vertical asymptote or a hole. At vertical asymptotes or holes, your graph is discontinuous and the domain does not exist for that point. So it really doesn't matter. Anything that makes your denominator 0 is going to be a problem for your domain. So if I look at this first problem, what is my discontinuity? Where's the place that I've got a issue with my domain? Is it 5? Is it a vertical asymptote or a hole? Vertical asymptote, because it does not cancel with the numerator, right? So it doesn't matter if it's a vertical asymptote or a hole, but it is a vertical asymptote here. So whenever I'm doing domain for this, there are, oh gosh, here, let's get rid of that. There are a couple ways that I can write this. One way, my favorite way for them to write it, is to write it like this. X does not equal 5. Sometimes they'll say all real x's such that x is not equal 5 or something like that. But they just say everything but 5, right? That I like best because it's the easiest to talk about, right? But they sometimes use interval notation instead, where they'll say negative infinity up to 5, and they'll use that union symbol 5 to infinity. And because they're using parentheses, that means the 5 would not be included. But we're going from negative infinity up to 5, not including 5, and then 5, not including 5, up to infinity. That's everything but 5 right there. I prefer to write it this way if given a choice, but sometimes these will be multiple choice questions. Okay, so we can do these pretty easily from just the equation. We're going to go ahead and do domain for all these first. So domain for the second one. What can x not equal here? I think I heard What have you got, Gracie? What'd you say? Okay. It's not 2. It's -2. Opposite sign. Because if I plug in -2, it'd give me a 0 in the bottom. And there's another number. What would it be? +3. Okay. Now, Gracie, which one of those is where the whole is at? The -2, because that cancels. But it really doesn't matter for domain, right? We don't care which one's which. Both of those are considered discontinuity, so it doesn't matter. Now, I really don't like it whenever they do interval notation here, because you would have to do -infinity up to the lowest one, which is -2. Then you would have to do -2 to 3. I should be using a union symbol there. And then you'd have to do 3 to infinity. Okay. 10. The nice thing about this is we don't have to factor here because we only care about what would make the bottom 0 here. So whenever I'm looking at this one, Mavry, what number would make the bottom of this 0? Very good. So we could just say x does not equal +2. Or if they're using interval notation, it'll look like this: -infinity to 2, union 2 to infinity. Okay. I don't know if that's a whole or a vertical asymptote because I didn't factor the top, but for domain it doesn't matter. We don't have to do that. Hannah, what about the last one? Perfect. X cannot equal -3/2. This one's a little tougher. We can't just use the opposite sign, but we could do 2x plus 3 equals 0. We would subtract that 3. Only do the bottom, yes. Because the numerator can be 0. It's okay if it is 0. And so that would give us that -3/2. They might use interval notation. Like this. Instead. So domain is really the same thing as wholes and vertical asymptotes, except for you don't care whether it's a whole or a vertical asymptote. So it's a little easier. You don't have to factor the top for that. Now, we're going to do range primarily from the graph. So whenever we're looking at range, we're going to see a few different things that can happen for this. The big thing is that most of these functions have a horizontal asymptote. So if they have a horizontal asymptote, that means that there's like a y value there that the graph never touches. So if I graph number 8 right there, f of x equals 1/x minus 5. And so if I graph this, it appears to have a horizontal asymptote. If you like zoom out, like it's getting closer and closer to that x-axis, but it's not crossing it. I could also like type in y equals 0 and see, oh yeah, if you zoom in right there, looks like it's touching, but it's not. Classic asymptote behavior right there. So if I have a horizontal asymptote at 0, that means my graph never touches y equals 0. So my range for this, let me switch colors. So I'm doing range. My range, I could just say y does not equal 0. Or if they use interval notation, it will be -infinity to 0 and 0 to infinity. Okay. Everywhere else, if you look at that graph, if you're thinking about, remember with this we can kind of sort of think about like the lowest point on the graph and the highest. Your lowest point on the graph, well, that would go down to negative infinity. The highest would be positive infinity. It's just that 0 where you're not going to have any value right there. Let's look at 9. We're going to have x plus 2 over x minus 3 times x plus 2. So if I look at this graph, I still have my horizontal asymptote right there. It's still at 0, right? It looks pretty much the same. The vertical asymptote is in a different spot, but that horizontal asymptote looks the same. So, Hannah, what would I write for my range on that one? Good. We can say y is not equal to 0, or negative infinity to 0, the union 0 to infinity. 4.4, is it starting to show up now? Okay, good. When we get this done, we'll look at that. Past work, okay. Good. Are other ones of you seeing it if you click on past work? Yours has still got nothing. Leave it up. Let's just wait. Maybe by the time we get it done with notes, it'll be there. Yeah, 4.4 is the one that we'll need. Okay. Let's do these last two, and then maybe everybody's Amplify will be up. So here, now this one's a weird one. Let's look at this graph. All right, now this one, we got to think, we're thinking lowest to highest here, but you've got a big gap in the middle of this graph, right? So I would actually prefer very much to do my range with our interval notation here. So if I'm looking at that graph, what's the very lowest the graph is going to go? If I look, this keeps on going down, right? It would keep on going down. So it goes all the way down to negative infinity. So my range goes down to negative infinity, but then, it's a little hard to see right here. I'm going to zoom in a little bit. It stops right here. There's like a high point, right? You need to zoom in because there's also two x-intercepts right there next to it on either side. That graph is like its highest point that it gets to is right here. Which coordinate should I use, the x-coordinate or the y-coordinate? Y, because range is y, right? So 0.0718. Okay, so we go from negative infinity up to 0.70718. Then there's a big gap. We got nothing till we get over here to this point, right? We got like a low point right there. So 13.9282. And then, what does that go up to? That keeps on going up forever, so it's infinity. Okay, I do like interval notation on that. The other way they'll write that is, oh, well, they won't use an x, they'll use a y. Y is less than 0.0718, and y is greater than 13. Actually, I guess it could be or equal to 13.9282. And you might see either one of those. Okay, our last one here is a little tricky. because it has a horizontal asymptote, but it's not at a whole number. So f of x equals x minus 5 and 2x plus 3. So if I look here, it originally looks like it's y equals 0. That looks to be it. But if I go full screen here, that's not my horizontal asymptote because I actually cross that graph right there. So 1 seems promising, except for it crosses the top part. So it's not a whole number, it's somewhere in between these. And it's a little difficult to get it perfect. Now, the good news for you is if I ask you for one of these, I'm going to give you answer choices, and you should be able to see, oh, yeah, it's 1/2 is where it is. So if I give you one of these, we're going to have a test Thursday because we've only got one more section that we've got to do tomorrow. Then we'll review Wednesday and test Thursday. So if I give you one of these, it's going to be multiple choice, and you won't have to, like, you can just check your answer choices to see which one works. But on Delta Math today, you might get some like this, and it's not multiple choice, and it won't let me switch it to multiple choice. So another trick right here. Those horizontal asymptotes happen when you've got like the same degree variable on top and bottom. What number is in front of this x right here that's on top? There's not one there, but it is a 1, right? So my range is going to be y cannot equal, just divide these two numbers, it's going to be 1/2. The 5 and the 3 don't like affect it, really. It's just the numbers in front of the x's. You only need to know that for Delta Math, otherwise it's going to be given to you as like a multiple choice question there. Or they may do -infinity up to 1/2 union 1/2 to infinity. Okay, questions? All right, everybody flip over to their Amplify assignment. It's not letting me refresh it here. It's not letting me see my usual teacher tools, but I did have at least a couple of you that said it was showing up. Super slow. Well, now I can't even put it up on the screen for us to see it. I think we're going to have to abandon our Amplify assignments, which means for your Delta Math, I'm going to put in so we can get a little extra practice. Let me see if I can adjust this. Do the first one and the 5th one right here together. So let's look at what's going to happen here. It is going to ask us for all of this different stuff. Horizontal asymptotes, vertical asymptotes, x-intercepts, y-intercepts, and holes. Okay? So x-intercept and y-intercept are not really things we've been focusing on, but that's just where it crosses the x-axis or where it crosses the y-axis. So it should be very simple to find, and it's a good reminder because it is something that they ask us to find on the problems. So let's start by graphing it. So if I go over here, I've got f of x equals 3x plus 9 over x squared plus 3x. Okay, so for this, let's start with that horizontal asymptote. Okay, If you just do like y equals 1 or y equals any number and hit enter, it'll put you a slider right here, and then you can just like move that vertical asymptote anywhere. Where does it look like the vertical asymptote is for this one? I'm sorry, I'm saying vertical, I mean horizontal. Looks like it's at 0. If you zoom out some, it does appear to be 0. We are going on looks primarily here. There might be a few where we've got to sort of guess at it a little bit. In that case, you could like divide the numbers, but don't divide them here because it looks like it's 0. You can tell. All right, so we got a horizontal asymptote at y equals 0. Vertical asymptote, if I go back over to my graph, it looks like it's also 0. So let's see, x equals 0. Yep, that's it. So I've got x equals 0. Beautiful. I'm going to skip x-intercept and y-intercept. I'm going to go down here to the whole. Now, I can, on Desmos, look for a hole. Oh, I think I did see one right there. I believe it's right there for -3. So you might be able to find it from Desmos. The other way, think about this. I'm just going to type it up here. What could I factor out of the numerator? All it has is a GCF. What could I pull out? I can't take an x out of the numerator. In the numerator, 3. I could take a 3 out, so that I'd have 3x plus 3. And in the bottom, I could take an x out, so I'd have x times x plus 3. All right? So right here, that x right there, that's where I'm getting my vertical asymptote. That's the x equals 0. Right here, that's where I'll have the hole. So where's my hole going to be? What's the x-coordinate of it? -3. Okay, now when I look at my delta math, it asks for the x-coordinate. It also asks for the y-coordinate of that hole. Some of these you're going to be able to tell from the graph. Some of them you're going to have to guess on. This one I'd say you should be able to tell. Like, so if I go find that hole, what's the y-coordinate of that point? -1 there. So I'm going to put in -1. You're going to get some of these that are not whole numbers. Just guess. It's probably going to count it wrong. But that's okay. I am not concerned about whether or not you know how to do this, but I think the rest of this activity is very good. I just can't assign it without asking you that part right there. So x-intercepts and y-intercepts are not necessarily this part of the curriculum. We've already done those back when we were doing features of graphs earlier in Unit 1. But an x-intercept and a y-intercept is just where it crosses the x-axis. So where does my blue graph cross that x-axis? Nowhere, because it has a horizontal asymptote, right? It doesn't ever touch 0. So I would say no to that. What about where does it cross the y-axis? It doesn't. So for this particular problem, I would say no x-intercept and no y-intercept for that. So this is what we should have on that first question. We should all have the same question too, so make sure you got those right. Okay, so we should have that. Everybody got that one? All right, let's pick another. I'm going to pick another one to do. Let's do this one. Yeah, we're going to do this one. It's way crazier, right? But it's still the same things that you're looking at. The good thing about these are they're already factored for you. You don't have to factor them. So I've picked the 5th problem there. It's the first one that says L2 out to the end. So let's just graph this right here. Okay, so when we're looking at this graph, it's going to ask us about horizontal asymptotes first. We'll just start with a y equals 0, see if that looks right. Make sure that's not actually a point of intersection. They don't cross there. So looks like it's y equals 0. You're going to see y equals 0 show up quite a bit, not on everything, but quite a bit. So horizontal asymptotes, there is one, and it is at y equals 0 for that one. Holes. Holes are hard to find from the graph. They should be pretty easy to find from this equation because it's already factored for you. How many holes are we going to have? We got 2 of them. Okay, holes are where they cancel. The x-coordinates of these should be easy. So what is my x-coordinate here with this x plus 2? What do I use? -2. What about for the x plus 6 that cancels? -6. Okay, here's where your guessing is going to have to come in. Because at -2, we're going to go find the hole. There it was. And then we have got to guess at the y-coordinate of this. But you're not going to be able to do that very well because it's not a whole number right there. So I can see I've got like -0.3435 on one side, and I got -3.232677. Any guesses about what that might be? A lot of these are going to be fractions. It's okay. A fourth would be -0.25. So I think you're close, and your guess shall be good enough for me. I'll be happy with it. We don't have to know it very well. I think it's going to be a third, because a third is going to be -0.3 repeating, and that seems to be kind of between the two numbers that I'm getting there. So it's going to be -1/3 for that. Now, I don't really care that much about you being able to get that number, so just guess as close as you can get. If you can't get the fraction, like if you guess -0.25, Delta Math is going to count that wrong, but I'm happy with what you've got. The x-coordinate is what I'm going to be asking you for. At -6, I think we end up with the same thing again if I'm remembering correctly. At -6, that point's almost at the same identical place. It's kind of symmetric right here, isn't it? So I'm going to go with -1/3 again. Okay. Again, I will not be asking you for the y-coordinates on anything. But again, I can't take it off. Okay, so we got horizontal asymptotes, we got holes. I don't want to. I don't want to be scary right now.
You're scary. It's just intimidating because you're just a really nice person. So when you do get to where you're angry,
right.
It's a little
if I am angry, then that should be more scary. Yeah, every once in a while. I try. I don't have to be mean much anymore. Sometimes. I've had times I was much meaner.
really mean last year to me.
There were a few times, yeah. Second semester, I only have AP classes, and I don't think I yelled one time. Second semester. I haven't yelled at you guys, no. There's so few of you, I don't anticipate having to do that. Yeah. So, it's pretty obvious, and nobody in here has a terrible attitude and talks back to me or anything. Nobody in first period does either. They just, they're a little lazy sometimes. I hadn't had to yell. I've only yelled at middle schoolers in the cafeteria this year, really. So, I've done that a few times. Yeah, I actually have not had, in cafeteria, I've not had any trouble out of, I don't think any high schoolers in the cafeteria.
Middle schoolers are
Yeah, the middle schoolers are
They have
squirrely.
no spatial awareness.
Yeah.
Good for me. I don't either. I will push you to do a friend.
Yeah, they like to make a mess too.
They remind me, if you ever seen the movie Leo about a lizard, it's funny because these little elementary school kids run around and
They'll. The good thing about middle schoolers is they usually grow out of it some. They do. They do. They do. As a whole, maybe not every middle schooler, but most of them improve. Because I can guarantee you that your middle school teachers probably weren't like, you know what, these kids right here are just the sweetest, nicest kids. They are so mature. They never goof off. Yeah, there might be worse, but even you guys have made some growth. All right, let's go back to our vertical asymptotes. Where am I going to have vertical asymptote here? So -6 and -2 were our holes because they cancel. So the only other thing I have in the bottom is 4, but it would be a -4, and I can check that over here on my graph by typing in x equals -4 and seeing if that looks right. That does appear to be correct right there. That's what we're looking for. It's a little bit weird because both of your pieces go down, but that happens sometimes. It's okay. That square is what makes it do that there. Then it's going to ask us for x-intercepts or y-intercepts. Now, I had a horizontal asymptote at y equals 0, which is the x-axis. So am I going to have a x-intercept? No, there is not an x-intercept. So that is a none. Y-intercept, however, okay, let me hit the house button again. I am talking about where my graph, let me get rid of these two, where this green graph crosses the y-axis. Does your green graph cross the y-axis? It does here. That's not at a vertical asymptote or anything. So it's right there at -0.08333. Here is another annoying thing about Delta Math. It's going to count it wrong if you put that decimal in. I tried it during first period. It wants a fraction. Give me a guess at your fraction. 1/8. So if we do 1 divided by 8, no, too big. 1/4 would be actually twice that. It's going to be bigger. Because we won't think about, that's our number of slices in our pizza. Right. All right, let's say 16th, too small. Let's just keep going. There's a 15th, nope, not it. 14th, nope. 13th, nope. 1/10 is 0.1, so it's not it. 12th, there it is. It's a 12th. So if you can try to get a fraction for that, because it's hateful there. So it has 1 and it is 0, 1. It was it positive or negative? It was negative, wasn't it? -1/12. Let me double check it. Yeah, it's -1/12. All right, so here's what we should have on that one. Okay? Everybody got it? Okay, so we are not going to do the Amplify assignment because it's not cooperating. I just added in a couple extra Delta Math problems for you guys since you didn't get that practice with these. So this is what you're doing for the rest of the class. I'll be around to help whenever you're stuck on something.